Welcome everyone to this lecture on the chapter of laws of motion. So, in this video, we are going to discuss the pulley block system and the associated constraint relations and its applications in these three problems. After completing this video, in the next one, we'll be looking at more constraints like the rod and the wall constraint, rod kept on a hemisphere, and so on. So all these considerations will be taken up, but first let us see the question which we are going to do today. So let us begin. The first question which we have is a mass m is kept on a horizontal surface. The pulley is of negligible mass and smooth. A force F pulls the pulley uh, towards right. Now to find the acceleration of the pulley. So you have this figure, and there is a string which goes over the pulley. There is a block of mass m. It is kept on a smooth surface. There is a force F acting at the center of the pulley. So we are supposed to find the acceleration of the pulley. So how will we do it? So first, let us assume its acceleration as some value AP. Let's say the acceleration of the mass m is some value A. So, like in the previous video, we drew a lot of diagrams of the pulleys itself, and you know that if the force F is acting at the center of the pulley, then the force which is applied by the tension at the sides of the pulley is half of that force. So, if we are saying that the tension force acting is T, then the force acting, the net force acting should be balanced, and we would say that F is equal to sum of the two tensions 2T, and that is the force acting in this direction. So this implies the tension is equal to the applied force divided by 2. Now this tension force would now act in turn on the block, which is kept on a smooth surface, and the mass of the block is m. So the acceleration of the block should be the force acting on it divided by the mass acting on the mass of the block. And the acceleration of the block. Um, so the analysis of the block is pretty easy. There is a force F by 2 acting on it, its mass is m, so its acceleration is m. And what about the constraint relation part? So let us write the constraint relations for this equation. So this string, the red string, it is connected to the wall at this point, at this point, at this point, and at this point. So these are the 4 points at which the string is connected to the system. So let's say the tension T into the speed of the ball, which is 0, minus tension T into acceleration of this point. So this point is moving to the right with an acceleration of the pulley, which is AP, and the direction and the angle between tension force and the acceleration of this point is 180 degree. The pulley is moving forward, tension is acting in backward direction, so there is a negative sign. One more expression for this tension would come out as tension T into AP and tension T into A, that is equal to 0. So we would say that 2 times acceleration of the pulley is equal to A. So acceleration of the pulley is equal to A by 2. So this is the value of AP, and we know that acceleration of the block is F by 2m. So the acceleration of the pulley would be F by 4m. So this would be the acceleration of the pulley which we require. Next we have the system We have a system of multiple pulleys and a block connected in this way. So let us draw it. So we have a block. And the block is kept on a surface. So the block is connected via pulley to the system. So let us say this pulley is somewhat like this. And this is the block of mass m. And this is the block of mass 3 kg. This angle is given as 37 degree. We are given that the acceleration of the block is in downward direction. Its value is 1 meter per second square. And the mass of the block is some 7.5 kg. So we are supposed to find the value of block M, capital M. All surfaces given in the system are smooth. The acceleration of the block 3 kg mass is 1 meter per second square down the incline. Find mass M, the tension in the string, and the acceleration 7.5 kg and M mass. Okay. So I think we can evaluate tension directly. We'll just draw the force body diagram of the 3 kg block. So 3 kg block, the gravitational force is acting in downward direction. Its value is some 3g. Let's say it's making some angle 37 degree with the incline. So we know that the angle of inclination is the same angle which the weight makes with the normal. The normal force is acting in vertically along the normal, not vertically upwards. The tension force is acting like this, and we know the acceleration is 1 meter per second square. So we'll say that 3g sine 37 degree, that is the component of gravitational force in this direction, minus the tension, the gravitational force, the downward force minus the force along the incline, is equal to the mass of the block into the acceleration of the block, that is 1. Sine 37 is 3 by 5 minus the tension T is equal to 3. The action to gravity G can be taken as 10 meter per second square. So we'd say that AIIMS minus T is equal to 3, and we'd say that tension is equal to some 15 meters. So the tension force value have already been calculated. We have to find the value of mass m. So for that we'll be having to evaluate the accelerations of various systems. So we'll say acceleration of the pulley and the block is some a1, and the acceleration of mass m is some a2. It is in downward direction. That is we have chosen, and there is only one strain. So writing the constraint relation, tension is acting in upward direction at this point. Acceleration is in downward direction. So we'll say minus t plus tension T into A1 plus tension T into A1 from these points. These are the points which we are considering. Tension is acting in rightward direction and acceleration A1, and then tension T minus A2. So minus T A2 is equal to 0. Tension gets cancelled out, so it gets minus 1 plus 2A1 minus A2 is equal to 0. Do we know the force is acting on 7.5 kg block. So the force is acting on 7.5 kg block is via this pulley, and the forces acting on this pulley is simply the tension 2 times. There is no friction over here. So it's a the only force is acting on the mass m, or the 7.5 kg mass, not the mass m. 7.5 kg mass, we would say that force would be 2t is equal to 7.5 times acceleration. So what is the acceleration? Acceleration is a1. The tension T is some 15 newtons. So we would say 30 is equal to 7.5 into a1, which gives the value of a1 as 4 meter per second square. And substituting the value of a1 in this equation, we would get minus 1 plus 8 minus a2 is equal to 0. So the a2 acceleration a2 is simply 7 meter per second square. So that is the acceleration of the second block. And what is the mass of the second block? So we know the value of tension already, right? The value of tension is 15 newtons, and the acceleration of the second block is 7 meter per second square. So it's a, if we draw the FBD of mass m, we would say the tension force T is acting in upward direction, and the gravitational force capital Mg is acting in downward direction, and the acceleration of the whole system is in downward direction. That is what we have chosen, a2. So it's a mg minus t is equal to m into a2, or it's a m into g, which is 10, plus a2, which is 7, is equal to the tension T, which is 15 newtons. Or say capital M is, so have we calculated the value of tension T? So tension T was 15, so 15 times 2, that is 30, and 30 divided by 7.5, that is 4. So from that we substitute the value of A1 here. That gives 8 minus 1, that is 7 minus a2 equal to 0. So that gives acceleration of the second block equal to 7 meter per second square, and then we substitute that value over here. We say mg minus t, that is the tension acting in upward direction, is equal to mass times acceleration of the second block, which is in downward direction, which we had chosen. So we'd be able to say that yes, this sign would be negative sign, yes, because this sign would come here. So this would be 15 minus 10 minus 7, that is 3. So that would be equal to 5 kg. So that is the value of the mass of this unknown block. So this is a good question of different kind, in which rather than calculating the acceleration, we are given the acceleration and we are supposed to calculate the value of mass of the unknown block. So let us move to the next question. In this question number 7, we have a system like this, and we are supposed to find the acceleration of the system. So mass capital M, both these masses are M, and a force F is being applied. So obviously we would be required to write the constraint relation. So let's say acceleration of block number 1 is a1, acceleration of block number 2, let's say that value is some a2. So let us write this string, draw the string properly. So since the string which we have, again we are having one string only, so it's a tension T, only a single tension can be taken. If there are more than one strings, then you would say you would take tension T and tension T dash, and you would have to decide that for which a string you have to write the constraint relation. But since there is only one string, so we don't have to decide in this case. Otherwise, we already know when the string is connected, the string which is connected to all the blocks or the most amount of blocks, that string is taken. So let's say the acceleration of block number 1 is this block is A2, this block is A1, that is what we have already chosen. Let's start writing. So it say that tension T into A2 with the negative sign, T into A1 at this point, T into A1 at this point, T into minus T into A2 at this point, minus T into A2 and T into 0. So this would gives us 3A2 equal to 2A1. So that is the relation which we are looking for. And in terms of force, what are the force acting on the block number 1? Let's say this is the block number 1, this is the block number 2. So on block number 1, the forces acting are simply 2T towards the right direction, because these are the only forces. So 2T divided by mass m should be equal to the acceleration A1. So this is for A1 mass. And for the second mass, we'd say the forces acting are F and 3T in the rightward direction. And the acceleration is A2, so you will write F minus 3T is equal to m into A2. So we write F minus, we can eliminate tension easily. So we would say 3 is equal, tension T is equal to MA1 divided by 2 is equal to MA2. And let's say we replace the value of A1 with A2. So it's a minus 3 by 2 M. And the value of A1 we are replacing with A2. So we write A1 is equal to 3 by 2. A2 is equal to MA2. So this should give us F is equal to 13 upon 4 M into A2, and this implies 4F divided by 13M is the acceleration of the block 2, that is this block. This is the block which we are considering, that is the block 2. This is the block which we are considering, it is block number 1. Acceleration of block number 1 is simply 3 by 2 times the acceleration of second block, which is 4 by 13 into F by M. So this would come out to be some 6 by 13 F by M. So with this we are done with the idea of pulley block systems and the idea of constraint relations in pulley block systems. So next we'll be taking up with other kinds of constraint and we'll be moving on. So thank you for joining this lecture. I hope you learned something new in this one. Have a nice day.